So our lesson today is going to be on area. So just a reminder of what the area formula is. The area formula for a rectangle is equal to length times width. So if I have a rectangle with the following measurements of 3 and 4, the total area of this rectangle is going to be equal to 12 square units. So the reason for that is if this segment is 3 long, I can divide it into 3 segments that are each 1 long, and 4 segments that are each 1 long in the width direction. And if you were to count the number of squares that fill the shape, there would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is what area is. It's the number of 1 by 1 squares that fill any particular shape. So this is the formula specifically for the area of a rectangle. Now, there are some other shapes, and they all have their own area formulas. We're going to take a look at the right triangle now. So this is going to be the area of our right triangle. And it has a formula of area is equal to 1/2 what's called base times height. So I'm going to draw a right triangle here. And it's going to have the same base as before, so 4, and a height of 3. And this is going to have half the area of that rectangle. And we can very easily see why. If I were to just draw another right triangle on this side, we would see that this is a rectangle with an area of 12. So therefore, half of it should be a triangle with an area of 6. So this is 3 units along this way and 4 units along this way. And this half will have 6 of the area of the rectangle, and this will have the other 6. Now, the side that's formed and forms a right angle is known as a height. And the other side is known as a base. Now, it doesn't have to be a right triangle, but in a right triangle, technically either side is the height because they both form right angles. In the average triangle, you need to know one side to be your base, and the other side for the height has to actually start at the opposite vertex. So hold on, let me relabel this triangle here. Normally we will label our triangle A, B, C. We usually, by default, label the measure of the sides, the name of the angle, but lowercase. So this would be lowercase b, lowercase c, and lowercase a. And the height would be formed by, we would pick a side. Let's say we pick side C in this case. Then we're going to draw the height from the vertice of the opposite side, so C in this case, and the height would be the line that forms the vertical distance. And technically, we can find the area of this shape by using the same formula. Area is equal to 1/2 the base times the height. So in this case, the height is little h. We'll say that's like, let's just give it a measurement. Let's say this was 5, and let's say C was like 12. So that means the area of this shape would be equal to 1/2 the base, which is 12, times the height, which is equal to 5. So that would be 60 divided by 2, which is 30. So that would have an area of 30, and that would be the area using the standard area formula. This formula comes from the area of a parallelogram. So a parallelogram has an area of base times height, which means one of the sides is the base, and the height is a distance drawn that forms a right angle from one of the vertices. And in a triangle, it's really the same thing as having cut that in half. So that's where this formula really comes from. Now, something that we're going to be learning that's actually new for our class is that you can find the area of any triangle using trigonometry, using SAS. So what I mean by SAS in this case is if I have a triangle here, and I know the measure of 2 of the sides, it doesn't matter which sides I know. Let's say I know this side is 6 and this side is 12, and I'm told that the angle between them measures 35 degrees. There is some sort of a height here, it's just we don't know what the measure is. So the height can be found using a trig ratio, and conveniently by using sine, you'll notice we actually only know one side of the triangle. We're going to find the second side, and we know an angle. So we know 2 of the 3 pieces we're going to use in our trig ratio. So it's the sine of angle, which is 35, is going to equal the opposite, which for this angle is going to be h in this right triangle, over 6. So h will be equal to 6 times sine 35. So this is the measurement of our height. So if we wanted to find the area, we can just write area is equal to 1/2 the base, which was 12, times the height, which is 6 sine of 35. And we could just use a calculator to obtain that value. But the point of this that is most important is if I were to replace all of these letters with other letters, so let's say this is angle A, this is angle B, and this is, actually let's call this one angle C and this one angle B. That would make this side here lowercase c, and this side here at lowercase b, and this side here at lowercase a. The formula here is really 1/2 c times b sine of a. So the formula is simply 1/2 the sine of the two sides being used, being multiplied together, times the sine of the angle between them. So that's the formula for the area of any triangle using SAS. So if we know two sides and the angle between them, it's just 1/2 of the two sides, so c times b, times the sine of the angle between them, because that is the height of the triangle. And that's pretty much all there is to find the measurement of the area of any triangle. So let's just use an example here. So we have we can just finish the example we had already. So we just plug that into our calculator. It's 1/2 times 12 times 6. Let me use my calculator. So it's 1/2 times, one of the sides was 12, the other side was 6, times the sine of the angle between them was 35. The area of that triangle was 20.65. All right, now we're going to work on